So in this lesson, I'm going to have a look at how we can solve equations which involve one of the trigonometry functions, so either sine, cos or tan. You will be introduced to a couple of diagrams that can be combined into one to help you do this. So these diagrams, which I've referred to as the cast diagram, related angles diagram, and then we can combine them into a little diagram that looks like this. This is what we will be using to help us find all the possible solutions to these trigonometry equations. Before we get to that, we'll explain where the diagram comes from and what it represents. If I was to ask you to look up values on your calculator for sine, cos and tan of different angles, you'd discover that some things, for example, if I said work out or pressure your calculator, do cos of 115 degrees or the sine of 129 degrees, these sort of things. Sometimes you'll get a positive value, sometimes you'll get a negative value, and it is related to the size of the angles, and they go in groups of 90 degrees, and I'm going to talk about quadrants when I do this. So the way it's worked out, this little table here, and you can check this if you pause the video and check numerically. So if you pick an angle, for example, between 180 and 270, and you press the tan button for that, you will find that it's got a positive value, whereas if you chose an angle between 270 and 360, so 300 for example, and did tan of 300, you'd discover it was negative. So it's that sort of, you can check through this or you can just learn this little diagram. What this diagram shows you is that the first quadrant is this one here, where I've got the A written, and what that A represents is that sine, cos and tan are all positive, right? So sine, cos and tan are all positive for angle sizes between 0 and 90, and again you can check that on your calculator. If you then pick an angle between 90 and 180 and do either sine, cos or tan, the only one that's positive is the sine, and hence the S going on in here. So in here, right, only the sine is positive, right, only sine angles. So cos and tan of anything between 90 and 180 is going to be negative. Between 180 and 270, the only thing that is positive is the tan. That's what the T is for in there. And then between 270 and then back to kind of the beginning, which this is the fourth quadrant, only the cos is positive in there. So I will refer to this as the cast diagram. So when you're drawing this out, you try to memorize to draw your diagram, two lines crossing over. Try and remember that you start bottom right, you put the word cast going round anti-clockwise, starting from the bottom right. Know that your first quadrant is this one here, and this is the one that we will use to get the other angles as we go on with this. We're going to talk about related angles in a little minute, but this one in here, the first quadrant angle, is the one that you will get from the calculator. So that's the first bit, is this cast diagram, and what it represents is whereabouts, or what is it that's positive within those sizes. So the A stands for all sine, cos and tan positive. Between 90 and 180, only the sine is positive. Between 180 and 270, only the tan. And then back to the beginning, between 270 and 360, only the cos is positive in there. So the other thing that is interesting about sine, cos and tan values is that there are some connections between them. So for example, if I pick these values, 30, 150, 210 and 330, and then I press the sine button on the calculator, notice that 0.5 is appearing with all of them for the sine values. However, 2 of them are positive and 2 of them are negative. When you look at the cos, you'll see that the same thing happens. You've got 2, this time it's 2 different ones that are positive. So in the first row it was the sine was positive here, then it was the cos has got 2 matching ones. So they go in pairs. So basically for each of these angles up here, you've got pairs of values for your sine, cos and tan that match. You've got 2 positives and 2 negatives. Now the way it's not just random angles that we've picked here, they are actually connected, and the first one is your acute angle, and that's the one that would appear in the first quadrant. So I'm going to refer to that as angle A. The one that's connected to that, this 150, is actually in the second quadrant, and in there, if you do 180 minus that 30, right, that's how you get the 150, the one that's in the same family, if you like. And then the next one that's connected to it, which is in the third quadrant, is the one where you do 180 plus that A value. And then the last one, which is connected, is 360 minus the 30, and that's how you would get that. Now let's check and see this next group of angles, 65, 115, 245 and 295. Does that work as well? And again, you can see they're going in pairs on each row, 2 positives, 2 negatives. And if you look at the connections, right, if we use that as our A angle to get the 115, if I do 180 minus 65, that is 115. So that would be my angle in my second quadrant. To get to the 245, that would be 180 plus the 65, and that does give me the 245. And then the last one is 360, take away the 65, and that does give me 295. So that's how they're all connected. So this here is referred to as a related angles diagram, and basically what it's saying is there are 4 angles that are all in the same family. They've all got the same sign, cos, tan, goes in pairs, and we put all of that information in together, and this is the diagrams I mentioned already. And it does look initially quite complicated. We need you to remember the cast, but we also need you to remember how they are connected in terms of being able to get the angles that are in the same family, and that's a related angles diagram. So you can combine it and draw your little cast diagram, and you can just memorize these x. The next one that's in the same family is 180 minus x. The one after that would be 180 plus x, and then the last one is the 360 minus x. So they're the 4 angles that are related. At any one point in time, you're only ever going to be working with 2 of them. So we're going to have a little look at how this works with our solving trig equations. So this first bit, if you were trying to work out, solve the sine of what angle equals 0.5 for angles of x between 0 and 360. Now we know what the sine graph looks like. So if the sine is equal to 0.5, that's roughly about there. If you look along, you can see that there are actually there are going to be 2 values where you get the sine being equal. So there's 2 sizes of angles where the sine is equal to 0.5. Now when you go to your calculator to do something like this, you'll only get 1 of those values. So this is where the cast diagram and the related angles comes in. So in the first instance, what I'd be saying to you here, what you need to write down for yourself is you need to say, right, so the sine is positive. So where does that happen? In terms of my cast diagram, I'm going to put a couple of ticks so I know that that means I'm looking for an angle in there, because all positive. That S means that the sine is positive in there. So this is where I'm going to be looking for my two sizes of angles. I'm going to be able to get the first one from the calculator. So by doing this gives me my angle A that I would be talking about. I'm going to go sine to the minus 1 of 0.5, and if you do that on the calculator it gives you the angle of 30. So that's the first solution, but the next one, your 180, now we've written 180 minus, actually I'm going to change those to x's, right, so we can write down there that we're dealing with x's, so x equals and x equals, and to get the second quadrant angle, right, which is the one in the S box in here, you do 180 take away the 30, which gives you 150. So your two solutions, or your final solution, you need to list both of those, so you get x equals 30 and you get x equals 150 degrees. Those are your two solutions, and you can check on your calculator. If you press sine of 30 you will get 0.5. If you press sine of 150 you'll also get 0.5, but this one you needed to work out, and this is why you need to know these connections. So let's look at the examples on your pages. So the first one, this is on page, in your notes, page 43. It says you can recognise the trigonometric equation because it will ask you to solve for angles between 0 and 360. So solve for 0 less than or equal to x less than 360. You're going to be using the inverse on your calculator, so that's like sine to minus 1, cos to minus 1, and so on. You will need to use your cast diagram, and you need to be able to come up with your two solutions. So for this one here, we're trying to solve the cos x equals this value. So what do we know? We know the cos is positive. So what I'd be looking for you to do, you would sketch your little cast diagram, and from that we can see if we tick, so we've got cos is positive. So where does that happen? Well, we know it happens in there because all A stands for all positive. In here it's only the sine that's positive in the second quadrant. In the third quadrant it's only the tan, that's what the T is for, whereas in the fourth quadrant the cos, only the cos is positive in there. So the two angles that we're looking for have got to be in the first and the fourth quadrant. So first quadrant angle, that one you get from the calculator. So you're going to go cos to the minus 1 of 0.456, and that would give you your angle x would be equal to 62.870, whole load of other digits, so we will round that to 62.9 degrees. To get the angle in the fourth quadrant, you then need to be doing 360 take away the one from the first quadrant, so 360 take away your x, 360 take away 62.9 would leave you with, in this particular instance, 297.1 degrees. So my final solution is these two values. So I'm going to write down solution x equals 62.9 and also x 297.1. So two values when you do that. Second example on your page, you're trying to solve sine x equals a negative value. Now between 0 and 90, which is where you get the first angle, all the angles are all positive. So we first of all ignore the negative so that we can find the angle in the first quadrant. So to get the first quadrant angle, we're going to do sine to the minus 1 of 0.87, and that, if I do that, that does give me 60.575, whole load of other digits. I'm going to call that 60.6. So we would have 60.6 degrees. However, one of the things I need you to notice here, right, as I've already said, the sign is negative. So we're going to look at where does that happen. So clearly not looking for a solution in the first quadrant because everything is positive in there. The second quadrant, the sign is positive in there, so we don't put a tick there either, but we do put a tick in the third quadrant and in the fourth quadrant because the sign is negative in these two places. So that's where our two angles are going to come from. However, as we already said, we need to work out that first quadrant angle, and we've already done that, but that is not one of our solutions. So our solutions come from the third quadrant, and we do that one by doing 180 plus the first quadrant angle, which is 60.6. So we end up with 240.6, and your fourth quadrant will be worked out by doing 360 minus the 60.6, and you get the answer of 299.4. So your two solutions that you use, make sure you don't use the first one here, you'd end up with solution x equals 240.6 degrees and x equals 299.4 degrees, and that's your two values. Now, the two examples we've looked at so far, you were given sine x equals and cos x equals a value. However, what's more common and what you're more likely to meet in the exam is that you will sometimes need to rearrange the trig equation in the same way that you would do with ordinary equations. So when you have things like x plus 3x and so on, so x plus 2 equals a number and you subtract the 2, so it's the same idea here. Right, we have this equation, so we have cos x plus the 2 equals 1.4, so we're not trying to get the x on its own at the moment, we want to get rid of that plus 2, so we do the opposite by subtracting 2 from each side of that equation. That allows us then to get to an equation that looks like the ones we just had a minute ago. So we end up with cos x equals negative 0.6. So what do we know? We know that the cos is negative. So from your CAS diagram, and this is all you would need to do, whereabouts is the cos negative? So not in the first quadrant, but in the second quadrant, yep, cos is negative in there, and also in here. Now put a little star in the first quadrant because remember that we need to get the angle between 0 and 90 to help us get the other angles. So what we do, work out that first quadrant angle by ignoring the negative. So we do cos to the minus 1 of 0.6, and when you do that on the calculator you get 53.130, whole load of other figures, we'll round that to 53.1 degrees. But remember, right, that is not my solution, so I'm putting a little star beside that. I do, however, need to get the one in the second quadrant, so my second quadrant angle, I will be doing 180 minus the 53.1. But do that on the calculator, I get 126.9. And then my third quadrant angle is 180 plus the 53.1, so we end up with 233.1. So my two solutions, and you need to make sure you list clearly the two solutions that we're looking for, are these, the two that I've got in red there. So make sure you don't include the first quadrant angle here. And your last example, same sort of thing. You've got 5 sin x minus 2 equals 0, and you would rearrange that so you'd have add 2 to each side, so you would have 5 sin x equals 2, and then we want to isolate the sin x by dividing by that 5, so we would get sin x equals 2 over 5. So clearly from here the sign is positive, so producing a little cast diagram and putting ticks where you need the cost to be, the sign to be. So between 0 and 90 everything is positive, so that's what A is. Between 90 and 180 only the sign is positive, and we're looking for that angle. So that does mean that we're going to look in the first quadrant and also in the second quadrant. So you're working for this first quadrant, you go to the calculator, you do sin to the minus 1 of, use your fraction key, 2 over 5, and you will get the angle 23.578, whole load of other digits, so we'll call it 23.6 degrees. And then in the second quadrant you would get 180 minus the 23.6, and that would be 156.4. So your final answer here is these two angles grouped together. So your solution is x equals 23.6 and x equals 156.4 degrees. So now it's time for you to practice this. So please make sure you draw the little cast diagram and that you use, in summary, right, the two things you should be using are the cast diagram and also the related angles, which basically means once you've worked out the one between 0 and 90, like this one you get from the calculator by doing sin to the minus 1 or cos to the minus 1 or tan to the minus 1, depending on what the equation is. But the other ones that are connected to that are 180 minus that angle, 180 plus that angle, and then 360 minus that angle. So it depends on whether you're looking for a positive or solving a positive or a negative one, but you collectively need those two diagrams together. So it's your turn to practice now.